To solve this first equation, we need to get rid of the parentheses before we can combine like terms. So what I'm going to do is distribute the 8 as well as the 3, and that will give me, let's see, 8 times 4 is 32, plus 8x, and then on the right side we have 9x minus 3, and then minus 8 at the very end. On the right side of my equation, I can combine the negative 3 and subtract 8, so that's going to be negative 11. I can't do anything to the left side of my equation, because those are not like terms. It's at this point where I have to start adding or subtracting things to both sides of the equation. I think what I'm going to choose to do is add 11, and that gives me 43 plus 8x is equal to 9x. And then I'm going to subtract 8x, and I'm left with 43 on the left, and actually just x on the right, making 43 the answer. For question 2, I see that there are fractions, and a good approach would be to cancel all of the denominators. So to start with, I need to know that the least common denominator for these fractions, you could put a over 1 there if you'd like. So between 4, 1, 3, and 2, the least common denominator is going to be 12. So for my next step, I'm going to multiply every single term by 12 over 1. So that is 12 over 1, and that's going to be multiplied to x plus 1 over 4. Then I get minus, again I'm going to multiply by 12 over 1 times 1 over 1. Okay, this is going to be equal to, again I'm multiplying by 12 over 1, and that's being multiplied to x over 3, then plus 12 over 1 times a half. By doing this, we're going to cancel every single denominator. 4 goes into itself once, it goes into 12 3 times. Nothing cancels in the next fraction. 3 goes into 12 4 times. 2 goes into 12 6 times. Now I have to be a little bit careful here. This 3 is multiplied to this entire numerator, so I just want to make sure I incorporate some parentheses. So you get 3, and you get x plus 1, but that 3 is being multiplied to both x and 1. Then the next is going to be 12. This is equal to 4x, and then plus 6. It was important to include the parentheses here because you have to distribute that 3 to both terms, and this gives us 3x plus 3 minus 12 is equal to 4x plus 6. So what we did is, this is kind of a complicated equation, and we took it to one where there are no fractions in it. So the last thing to do is just combine like terms and put all the x's on one side. So on the left, we have 3x, and 3 minus 12 is going to be negative 9. And that's equal to 4x plus 6. I think what I'll do is subtract 3x from both sides. So I get negative 9 is equal to x plus 6. My last step is to subtract 6 from both sides, and that's it. I arrive at my answer. Negative 9 minus 6 is negative 15. That is equal to x. This is the solution to question 2. Same idea for question 3. I see there's fractions. I think what I'd like to do is cancel them. So I see we have a 5 and a 3. There's really a 1 here. So my least common denominator is going to be 15. So I'm going to multiply 15 over 1 to every single term. Now when I say that, this whole piece here is one term. That means I put 15 over 1 here, but that's it. These parentheses mean, okay, I'll deal with it later, but the 15 over 1 goes here. So I'm going to start this by writing. We have 15 over 1, and that is being multiplied to 1/5 and then x minus 4. Okay, we move on to our next term. And you could put 15 over 1 if you want to, but you can actually just write 15. 15 is being multiplied to 2. The reason I didn't put 15 over 1 is that, well, you don't have to write 2 over 1, you can just put 2. All right, but on the right side of my equation, okay, again, here we have 15 over 1, and that's being multiplied to 1/3, and then x plus 7. Again, because of the parentheses, the 15 over 1 gets multiplied here. It does not yet get multiplied into here. All right, so let's simplify all of this. All right, 5 goes into itself once. It goes into 15 3 times. I cannot cancel anything here, but over here, 3 goes into 15 5 times. Here is what is left over. We have 3 times x minus 4 plus 15 times 2 is 30. That's equal to 5 times x plus 7. Again, this trick of multiplying both sides by 15 got rid of each fraction, each denominator. I'm going to distribute in the 3 as well as the 5. And if I do that, I get 3x minus 12 plus 30 is equal to 5x plus 35. Okay, on the left side, I have negative 12 plus 30, that's positive 18. I still have 5x plus 35. I guess I'm going to subtract 3x. So I get 18 is equal to 2x plus 35. Then I'm going to subtract 35. I don't think I left myself enough space, but okay, we get 18 minus 35, that is negative 17, is equal to 2x. This is different. We're actually not quite done yet. We have to divide both sides by 2. And I'm going to leave my answer just like that. Dividing by 2 cancels those 2's. So on the right, you have x, and I'm going to leave my answer as negative 17 halves. You could put it as a decimal if you'd like to, or even write a mixed number, but negative 17 over halves is an answer to this problem. Okay, now looking at question 4. Nothing really special here. You could just multiply, let's say, this 0.2 into the parentheses and combine like terms. But there's actually a trick that you can do here. If you want to cancel the decimals, there's a number that you can multiply to both sides. And that number is 10. So I'll put that as my first step. I'm going to multiply by 10 to both sides. So what that's going to do is multiply this by 10, and then these two terms by 10 as well. The nice thing is, multiplying 0.4 by 10 changes it to 4. Multiplying 0.2 by 10 changes it to 2. Again, the 10 would only be multiplied to this number, not yet into the parentheses. Over here, 0.4 multiplied by 10 gives you 4, and 0.8 multiplied by 10 gives you 8. Multiplying both sides by 10 changes the equation to this. 4x plus 2 times 1 minus x is equal to 4x plus 8. So all I did was multiply each of these numbers by 10. And in doing so, I got rid of all the decimals. So let's see, I know I'll distribute in the 2. So I get 4x plus 2 minus 2x is equal to 4x plus 8. On the left, I have 4x and I'm subtracting 2x. That gives me 2x plus 2 is equal to 4x plus 8. I think I'll maybe subtract 2x from both sides. That gives me 2 is equal to 2x plus 8. I'll subtract 8 from both sides, and that gives me negative 6 is equal to 2x. If I divide both sides by 2, I have my answer, and that is negative 3 is equal to x. For question 5, I see that I have a 9 and a 3, and technically a 1 for this denominator. This means the least common denominator is 9. So I'm going to simply multiply that to both sides of the equation. Here's what I get. 9 over 1, that's multiplied to 1 plus 2x over 9. And I have minus, okay, again, I get 9 over 1 times, this is going to be 2 minus x over 3, and that's equal to, all right, on the right side, I'm not going to write 9 over 1. I'm just going to put 9 and multiply that to 1. I mean, there's nothing that's going to cancel in a fraction on the other side, so this is good enough. But I've multiplied 9 to both sides of my equation. Okay, next step. I'm going to cancel the denominators. These completely go away. However, here, 3 goes into 9 3 times. I want to be careful here. This is 1 times this expression. You don't need to write the parentheses, but if you want to be careful, I mean, you could say this is 1 times all of this stuff. So I'm just going to write it down that way, just to see what it looks like. That's 1, and it's multiplied to 1 plus 2x. Okay, next, I have minus 3, and that's multiplied to 2 minus x. And on the other side of my equation, I have 9. It's good practice that if you have a number, and here you have this fraction with multiple terms, to set up parentheses. Because this number is a 1, you could have skipped this step, because if you distribute this in, you're just left with 1 plus 2x. However, over here, you have to be careful by incorporating the parentheses. Well, anyway, this whole piece here, it's just 1 plus 2x, so I'm going to write that down. But on the next set of parentheses, you're not just multiplying in the 3, but you're multiplying in the negative 3 as well. So you have to be careful to change the signs on the terms inside the parentheses. So here's what we get. We get a negative 6, but we get a positive 3x, and this is equal to 9. So there's a lot of like terms on the left. We have a 2x and a 3x, which is 5x. We have a 1 minus 6, which is negative 5, and that's equal to 9. I think what I'll do here is add 5 to both sides, and this gives me 5x is equal to 14, and if I divide both sides by 5, I get my answer. I'll leave it as a fraction, but it is x is equal to 14/5. For question 6, so again here you don't need to multiply both sides by 10, but I'm going to use this trick in solving this problem. I see that if I multiply this by 10 and this by 10, and these two terms by 10, it's going to change them from decimals to whole numbers. But in this equation, if you multiply the left side by 10, technically you're going to multiply that 10 to the 3 first before it gets multiplied to the 0.1 and the 0.2. And here, if you multiply by 10, well, no problem. That's just going to become 5. If you multiply this by 10, you're going to change it to 7. So just to be careful, on the left side, if you multiply the first term by 10, you get negative 30 times 0.1x plus 0.2. Then you have minus, and 10 times 0.5 is 5. On the right, you have negative 7. So this was our first step. It was to, again, multiply by 10. It got rid of a couple of the decimals, but it didn't do anything to these two yet. Okay, my next step is going to be to multiply this negative 30 into the parentheses. It's at this point where I think the decimals are going to go away, when I multiply this and this. Let's see what we get. Okay, so negative 30 times 0.1x is going to be, well, it's going to be negative. 30 times 0.1 is 3, and we have an x left over. When I multiply negative 30 to 0.2, it's going to be negative. You get 6. And then we have minus 5, and it's equal to negative 7. So a lot of negatives in here, but negative 3x can't be combined with anything. Negative 6 and negative 5 is negative 11, and that's equal to negative 7. All right, I think I'll add 11 to both sides. This gives me negative 3x is equal to 4. I'll divide both sides by negative 3, and I have my answer. My answer is x is equal to, I'll write it as negative 4/3. You could leave the negative in the denominator or put it in the numerator. Either way, this is the answer to question 6. All right, this last problem is a little bit strange. Something's going to happen that we haven't encountered yet. But what we're going to do is take the same approach of try to solve this equation for x. And so far, we've always gotten a solution. Let's see what happens here. I'll start by, well, we don't have any decimals or fractions to worry about, so I'll multiply the 5 into the parentheses. I'll multiply this negative into the parentheses as well. If I do that, the equation becomes 5 minus 5x plus 2x is equal to negative 3 minus 3x minus 4. All right, let's combine like terms. On the left, I have 5 and minus 3x. On the right, I have negative 7 minus 3x. Okay, I guess, a couple of options. I think we could maybe add 7 to both sides. It's fine, you could do that. This changes your equation to 12 minus 3x is equal to negative 3x. And for my next step, I want to deal with the x's, so I'll add 3x to both sides. But this is weird. When I do that, on the left, I have 12, and on the right, I actually have 0. You could put 0x, but 0 times anything is simply 0, and we have this statement. 12 is equal to 0. That's a false statement. But all these steps are equivalent steps. And here's what all this means. If you end up at a false statement, you're just basically saying, well, okay, those things can't be equal. But if that's true, none of the previous equations can be equal either. Altogether, what this means is there is no solution to this equation. So I'll just put no solution. This is a possibility. It doesn't have to be that every equation has a number that makes it true. And here's an example of, well, it looked like we could solve it, but when we went through the process, it took us to a false statement. If that happens, the original equation has no solution. Maybe just as one final thought on this problem, we ended with 12 is equal to 0x. And it might be tempting to say, oh, well, divide both sides by 0. But you can't do this, and you can even check it on a calculator. In fact, I have my calculator here, 12 divided by 0, and it gives me an error message. Division by 0 is undefined. So here's another spot where if you got to this equation and you divided by 0 and your calculator told you error, okay, that's telling you that there's no number that makes this true. Again, this equation has no solution.